It's a whole new meaning for the term superfood. Stephanie Leyden shows us researchers at Worcester Polytechnic Institute are turning spinach, you ready for this, into human tissue.
Stroll through the produce aisle and you'll likely think dinner. But one person's meal is another's biomedical breakthrough.
One day over lunch, Josh had some spinach.
The leaves reminded Josh Gerslak of something central to his research here at Worcester Polytechnic Institute, the human heart.
And really that stem, it just shouted out to me that it was just like an aorta.
Gerslak is working on his PhD in Glenn Gaudet's lab. They're biomedical engineers focused on coming up with a way to help the millions of people who suffer a heart attack.
When someone undergoes a heart attack, there's an irreversible scar that forms in their heart muscle.
They've been trying to create something that could restore function to those scarred areas, a man-made version of healthy human tissue.
That's a nice leaf.
Which is why the spinach caught their eye. Like heart tissue, it contains a system of veins. Could blood flow through those spinach leaf veins to the rest of the heart?
Josh came back to the lab and kind of secretly did this because we didn't want people to think we were crazy.
First, he used a detergent drip to strip the leaves of color and everything else.
Here's an example of one leaf.
Aside from its shape and those veins, it no longer looks or feels like spinach.
You can see how stretchy it is.
The spinach is now cellulose, a material commonly used in medical applications. Now the test. Will the veins carry liquid? As you can see in these pictures, the answer is yes. Red dye flows through the spinach veins as blood through human veins. And this video shows what happens when researchers attach heart cells. They contract. You're looking at heart cells beating on a spinach leaf.
It's just incredible. Something as wacky as spinach could support these type of cells.
Spinach, the stuff that gave Popeye supernatural strength, in this lab is transformed into something that sounds like science fiction, a replacement for damaged heart tissue. It's a whole new field of research.
You think about how much spinach you can grow in your backyard. You can just imagine the number of patients that could treat.
Stephanie Leyden joins me now. Are you kidding me? I mean, what
stuff.
is this stuff?
Okay, this is either, you can look at it as produce or you can look at it as the materials of biomedical engineering.
Okay, obviously you're thinking of it as the latter. So that is parsley, that's cauliflower, and
this is
an apple or something? What is
this
that?
is a celery root.
Celery root, that's what I meant
These
to say.
are all things that these researchers are now looking at as potential replacements
For what?
for human parts.
For what?
The roots of the celery. They're interested in roots because they can grow up and down. They think about veins. They think about veins and arteries when they see stems like this. And would you like to guess what the cauliflower
Brain.
could replace? Close, lungs.
Oh my God.
They think. I mean, this is all experimental at this point.
How about the risk of rejection? I mean, I assume you have to clean it first. Before, no,
Well,
it's a joke, but go ahead.
Right. It doesn't have to be organic.
Thank you.
That process of taking away the color in the cells, decellularization it's called, removes everything. And what they're using potentially would be a person's own cells. So they think the risk of rejection would be low if they get to that point.
So what time, what are we talking about in terms of until spinach is implanted
It's
in my
years.
whatever?
They're still in the lab. They'd have to do human testing. It's years away, but who knows? They're optimistic.
But this passes the laugh test. This is not like science fiction stuff.
No, they're
yes?
quite serious. You know, these folks are biomedical engineers. They had been working in collaboration with plant biologists, people who are sort of in another field. So these are two fields coming together, and this is what we're seeing.
I will never look at celery the same. Let me tell you, Stephanie Leyden, that is a great story.
Thanks, Jim.
Nice to see you. Wow.